In question number 6, we have to find all points of discontinuity. Find all points of discontinuity. Function FD defined. The function is given by f of x is equal to 2x plus 3 when x less than or equal to 2 and 2x minus 3 when x greater than 2. Now can you guess how many cases we have to discuss?
3, sir.
3 cases. What are they?
So x less than 2, x more than 2, x is equal to 2, sir.
Hope now you have got it right.
Yes, sir.
Because at x is equal to 2, the function gets split up into 2 different subfunctions. The domain of f of x is divided into 2 intervals. That is minus infinity to 2. That is, as you said, it is closed interval 2. And here it is open interval 2 to infinity. But this 2 is going to be the connecting point for these two domains, subdomains. So the case x is equal to 2 should be discussed separately. So we have to take the case x less than 2, equal to 2 and greater than 2. Now let's try to draw the graph of this function by which we can get some hint about the continuity. It gets split at 2. So it is the point 2 comma 0. In x is less than or equal to 2, we have y is equal to 2x plus 3. That means 2x minus y is equal to minus 3. So this is how the graph would be. It will have the intercepts at x is equal to minus 2 by 3 comma 0 and the y-intercept will be 0 comma 3. So at the points less than 2, this will be the graph. This is up to 2. When it is greater than 2, we have y is equal to 2x minus 3. That from that we get 2x minus y is equal to 3. That means it has the x-intercept at 2 by 3. 2 by 3 comma 0 and y-intercept at minus 3. 0 comma minus 3. So the graph will be here, all it will be a dotted line, and at the point 2 it will cross at 1. So this is the point 2 comma 1, because when you give x is equal to 2 here, it will be 4 minus 3, that is 1. Y will be 1. So this is the point 2 comma 1 and this will be the point 2 comma 7. So can you guess, is the function continuous? In which interval it is continuous and where it is discontinuous? Anybody can answer. Yes? Any idea? When x is less than 2. சொல்லுங்க.
2x plus 3, sir.
இல்லம்மா, எங்க x less than 2 இருக்கும்போது
X less
ஃபங்க்ஷன்
than
வந்து
or
2.
equal to 2, sir.
x is equal to
X is less than or equal to 2, sir.
சரி, அங்க வந்து கண்டினியூஸா டிஸ்கண்டினியூஸா?
It's continuous, sir.
கண்டினியூஸ். கிரேட்டர் than 2ல
Continuous, sir.
கண்டினியூஸ். ஈக்குவல் டு 2ல
So it's discontinuous, sir.
எங்க
X greater than 2, sir.
greater than 2ல பாருங்க, we get this straight line. இந்த straight lineல ஏதாவது பிரேக் இருக்கா?
No, sir.
அப்பனா it is
Continuous.
continuous. அப்ப discontinuity எங்க வருது?
It's equal to 2, sir.
equal to 2ல தான் discontinuity வருது. So now let's check these three cases analytically. Case 1, when x is less than 2. X less than 2, you assume some point in x less than 2. So in x less than 2, f of x is 2x plus 3. Let C be a point in the interval x less than 2. So it is minus infinity to 2. So our f of c is equal to 2c plus 3. And limit x tends to c, f of x is equal to limit x tends to c. Our c is in the interval x less than 2. So f of x is 2x plus 3. That is equal to 2c plus 3. So the function is defined at all the points c in minus infinity to. Limit also exists at all the points minus infinity to 2. Also, these two values are equal. This implies for all c in x less than 2, or he can be specific with the interval, in all c in the interval minus infinity to 2, limit x tends to c, f of x is equal to f of c. This implies f of x is continuous if x less than 2. This is also clear from the graph. This is the graph of f of x and x less than 2, which is continuous. Now the case of x is equal to 2. It's a point where the function gets splits. So we have to consider the left hand limit and the right hand limit. So if you take the left hand limit, it is given by limit x tends to 2 minus f of x, which is equal to, by algorithm to get the left hand limit, is limit h tends to 0, f of 2 minus h. 2 minus h means in the number line, it lies to the left of 2.
Sir, I have a doubt, sir.
சொல்லுங்க.
So 2x plus 3 தானே சார் இருக்கு. அப்போ சார் 2 minus h ன்னு வருது.
This is the definition to get the left hand limit.
Yes, sir. But the given function is f of x is equal to 2x plus 3.
Yes.
So
We have not yet substituted the function.
okay, sir.
So 2 minus h will lie to the left of 2, where f of x is 2x plus 3. So this function is takes the value 2x plus 3, where x is 2 minus h. So it is going to be 2 into 2 minus h plus 3. In this, if you allow h is equal to 0, we get 4 plus 3. that is equal to 7. Because the limit is h tends to 0, you have h is equal to 0. Now let's take the right hand limit. Limit x tends to 2 plus f of x, that is equal to limit h tends to 0 f of 2 plus h. 2 plus h will lie to the right of 2. So 2 plus h will lie here. So in this interval, f of x is 2x minus 3. So it is equal to limit h tends to 0, 2 into 2 plus h minus 3. In this, if you allow h tends to 0, we have 4 minus 3, that is equal to 1. That means this is what we also saw in the graph of the function. So the left hand side graph, it is 2x plus 3. From this it move on and stops at the point y is equal to 7, that is 2 comma 7. And the right hand side graph starts from y is equal to 1. It is from the point 2 comma 1, it goes on increasing, keep on increasing along the path 2x minus 3. So at x is equal to 2, we see limit x tends to 2 minus f of x is not equal to, that is left hand limit at 2 of f of x is not equal to the right hand limit at 2 of f of x. So this implies f of x, x is equal to 2 is a point of discontinuity. And it is again going to be a jump discontinuity because the function is defined. The value of function at f of x equal to 2, that is f of 2 is equal to 7. The limit, the left hand limit and the right hand limit are not equal. Function exists, but the left hand limit not equal to right hand limit. Therefore, 2 is a jump discontinuity of the given function. Now let's take case 3. When x is greater than 2. So in that case, our f of x is equal to 2x minus 3. So now let's take any integer, any value c, any real value c in the interval 2 comma infinity, that is x greater than 2. So f of c is going to be, this is the case for all x greater than 2. So it is 2c minus 3. Also, limit x tends to c, f of x is equal to limit x tends to c, our f of x is 2x minus 3. That is equal to 2c minus 3. So we see limit x tends to c, f of x exists and is equal to the value of the function at c. This is true for all c in the interval 2 to infinity. So this implies f of x is continuous at x greater than 2. But the question is to find the points of discontinuity. So from all the three cases, we find x is equal to 2 is the jump discontinuity or simply point of discontinuity. You need not even specify the nature of discontinuity of the function f of x.